Hello everyone, welcome to this second video in this tutorial series Modern Python. And in this video we're going to get started with Python. So what we're going to do at the end of this video is we're going to create a simple program that just calculates the salary of someone given the number of hours they worked in a month and the hourly rate. So here I'm running this program, so it asks me to enter the number of hours someone worked. So if I enter, for example, 23, it's printed the name of the person and the salary that they enter in that month. So this is one simple program that we're going to create at the end of this video. So to get started, let's see first how we can communicate with Python. So first things first, if you remember in the previous video we created an environment for Python, and so before I get started I'll first activate that environment, which is called activate, and the name of that environment was NLP, so conactivate NLP. So you see here the name has changed from base to NLP, so now we are using this environment NLP. So first, to show how we can communicate with Python, I'm going to enter the interactive mode, and for the interactive mode you can just type Python and this will take you into the interactive mode. So if you can see here, I'm in the terminal in VS Code. So if you don't have the terminal open, you can easily open the terminal by going on terminal and then new terminal, and this will open up a terminal. So here I've already opened, so I won't do that. So I'll just go ahead and type Python and hit enter. And this now is now in the interactive mode of Python. So first it will show you the Python version that you're using, and here this is based on Anaconda. And from here we can now start entering commands communicating with Python. So for illustration purposes, I'll just show a simple calculation. We can enter, for example, 2 plus 5, and it immediately prints out 7. So this is an interactive mode. When you enter a command, the command is immediately run by Python. So how does this really work in Python? So Python has what is called the Interpolator. So as we know, a computer has a CPU, and the CPU can only learn machine language, which is just zeros and one, a very simple vocabulary consisting only of 2 words. There's only 0 and 1. The only problem is that you can't really program in zeros and 1 because we don't really think in zeros and 1, so it's a little bit tedious for humans, and the syntax for zeros and 1 is really complicated. So what we have here is a high-level language, so we type in a language that's close to English. So as you can see, the command I entered 2 plus 5 is like what we did in elementary school math. So the high-level language allows us to write in this kind of syntax, a high-level language. And then with Python specifically, it has an interpolator which translates this English-like language into machine language. So I don't really have to care about zeros and 1 because the interpreter will handle that for me. So moving to this high-level language, the vocabulary goes a little bit, but it's still small as compared to the vocabulary in natural languages, for example in English. So let's see this vocabulary. We just see how many words we are dealing with. So just type help and keywords. So this shows me the entire vocabulary for Python. These are just around 35 words. So these are called keywords because whenever you enter one of these, then Python knows that something is about to go down. So these are very special. They have special meaning. Whenever you enter it, then you want to enter something special. So as you can see, they're English-like. There's class, there's continue, there's def, there's del, and there are so many of them. By the end of this tutorial series, we'll cover all of them. They're just 35. So as you can see, it's only a small vocabulary, and the goodness with Python is that it's very easy to learn. The syntax is really good, and you can apply it across different problems. So with just these 35 keywords, we can do a lot of great things with these words, as you see as we go on. Okay, so that's the vocabulary for Python, and now I'll just continue entering a few commands, and here I'll just enter just addition, and you see that it immediately prints out the value. So the other thing that we might want to do is give these things some names, because names become very convenient. As you know, in the daily life, we all have names, and people can call our attention by just calling out the name. The person doesn't have to come and tap you or something for them to get your attention. You respond to the name. So the same thing we can do also in Python. We can give things names. So names in other languages, they're referred to as variables, but in Python they're really just names. They're not really variables. So let's see how we can give, for example, 8 a name. And here let me just say want to give it the name x. So just say x equals 8. So this is an assignment operator which just assigns the name x to 8. And if I do that, I hit enter, you see nothing happens, but it doesn't print out anything, but it has actually assigned the name x to 8. So now what has happened is that now this value 8 has the name x. So now whenever I want to use 8, I can just type in x, and you see it prints out 8. So we can do the same for 19. We can assign it a name, say y, and that's 19. So now y, if I enter y, see that y is 19. And we can do things now with these names, and this is where the power of programming comes in, when you start manipulating these names. So here let me just add x and y. So as you can remember, x refers to 8 and y refers to 19. So when I type x plus y, what I'm basically doing is 8 plus 19. So wherever there's an x, it will be replaced with the actual value 8, and the y just stands in for 19. So the addition is 8 plus 19. So if I hit enter, you see that now it prints 27. So now we don't have to carry around the actual numbers. We can just use the names, and they work just as things work in the real world. You can put your name on the contract, but the name actually means you, the person. The name on its own has no value. The value is that that name stands in for you. And same here, we have x standing in for 8. We have y standing in for 19. So the name itself, x and y, doesn't have any special meaning, except it stands in for something. So there are certain rules that we have to follow for naming things. So the first thing is that the name has to be letters, and it can contain some numbers and also underscore, but it can only start either with a letter or an underscore. For example, if I say the name is C9W, this will give an error because this is the wrong way. So if I hit enter, you see it gives a syntax error. So meaning this is not part of the syntax. And this is the way programming languages are. They can't, if you just don't follow the rules, it's going to say, no, I don't recognize this. There's a syntax error or any other error. So usually we make a lot of errors. So everyone does. So don't get discouraged when you are creating a program and you see some errors. Everyone makes some errors. So the only thing that you have to do is now to debug these errors. It's called debugging because these errors are considered as bugs. So what you can do for you to debug the errors is to just first delete the error. So the best thing on how to handle that is to first go to the end of the error and see what it says. So as you can see here, it says that this is a syntax error. And yeah, it gives a message at the end that this syntax is invalid. So it's not part of the language. So it will show a caret here, as you can see here, the one underlined here to show where the error is. So here you have to understand the syntax that you can't start a variable with a number. So it's because of the 9 that this has given an error. So how do we fix that? So we just have to follow the rules of Python. So we can say, if you want, you can say 9y is equals to 10. And this will work just fine because a name has to start with a letter, or you can start a name with an underscore, like that. That will also work. So these are the only things that are allowed in a name. You can have a letter, either capital letter or small letter, underscore, and a number. So you can have an underscore anywhere, and you can have a letter anywhere. But you can't start a name with a number. So those are the only rules that you have to follow considering naming things. Usually in a real program, you can't give a variable or a name, for example, X or Y or A or any of the letters. You want the name to somehow show the purpose of what is trying to name. For example, if you're naming a person, you would call the name person, so that when you just read person, you know that this refers to someone. Or you can say name of a person and you know that this is the name of a person. But if you say X is equals to John, or maybe if you don't even give X anything, but you plan to give it John later on, someone who don't know what X is meant for. But if you say it's name of a person, then someone immediately knows that that's the name of the person. And usually you have to consider yourself, the future you. Usually there's always a problem with the future self, because the way you think now is not how the future self will think like. So you have to make sure that your future self will understand what you are trying to do. Because when you just leave the code for a few maybe weeks, usually you don't remember what you are trying to do. And the more you gain experience by practice, some of the things that you'll be doing today will be like, what was I trying to do here? This is so dumb. So it's better you make the code as clear as possible, because what we do actually is to write code so that humans can read. It's not just for the computer to run. The first thing is for humans to be able to read. And that human, and those humans includes also your future self, because the future you is actually very different from the you now. So you have to always take care of your future self. So that's it about the names. And the other thing that we need to look at is the types. So just as in mathematics, we have integers, we have integers, we have rational numbers. In these artificial languages also we have data types. So if we look at what we have here, for example, 8, 19. So from mathematics, elementary school mathematics, you know that this is an integer. So even in Python, this is just an integer without any decimal places. But once we give it a decimal place, for example, if you say 10.0 or 8.0, then that becomes a float. It's no longer an integer. And the other thing that we have booleans. So these they're just two of them. You have false and true. So these are booleans. They're just two of them. So true, you can look at true as if it's a yes, and false as if it's a no. So these are the two booleans that we have. And the other thing that we have are what are called strings. So imagine you want to save the name of a person. How do you save the name? So here I'll just call name, just to stand in for name of a person. So you have to create a string, and for you to do that, you have to use these double quotation marks. So for example, here I'll say the name is John. So here we have the beginning of the string. So we start with a double quotation marks. So at the end of the string, you have to put another quotation mark. So these are called double quotation marks. So that works. So if I name, and it will show me that that name is John. So the other thing that we can do is we can use single quotation marks. As you can see in the print, it's shown with single quotation marks. So we can also say name is equals to, let me say Mark. So now if I say name, you can see that the name is now Mark. So what has actually happened here is actually something interesting that we can look at. So if you remember, in the first case, we've assigned this name to John. In the second case, we've assigned it to Mark. So what has happened to John now that now name refers to Mark? So in Python, there's what is called the garbage collector. So what it will do is, at this point, we've given the name to Mark. So now this one has remained, John has remained without a name. So what the garbage collector would do is that it will claim whatever memory John is occupying. So John will no longer exist in the program. The garbage collector will take care of that. So so this shows that you can assign a name to different things, but at any particular time in any given scope, you only have a name assigned to one thing only. So here, by giving Mark the same name, I've taken it away from John and I've given it to Mark. So John remains without any name, and therefore that this value of John will go. And this, if you see this, so as we said, this is a string. So it's just abbreviated as str. So that's a string. So so one thing we can do is we can also check the type of something. So to check the type, we just say, to check the type of something, you just say type. For example, here, let me say type name. And you see it is said name is of the class string. And I can do the same, for example, type y. And it's shown me that y is an integer. So if you see here, this is an integer. So if we say z is equals to 10.0, if I say type of z, you'll see that z is now a float. So let me create another variable. Let me say w is equals to true, and I can say type of w, and you see that that's a boolean, which is just abbreviated as bool. So that's with names and data types, and there are a number of data types that we're going to cover later on. But for a start, we can just look at these few just to get us going. So that's basically how we communicate with Python. So now let me go to actually writing the program. So as you can see here, we're entering the commands in the interactive mode, and we can't really share this with someone else to run it. We write, it runs, and it goes. If I exit, if I close this, we lose everything. We haven't saved anything. So what we usually do is to write a program in a file. So I'll leave this interactive mode by typing exit. So that leaves the interactive mode. So I'm back in the terminal. So I'll just clear everything. So now let's see how to write. I'll just minimize this. So let's see now how to write a program. So let me just clear this. So I'm in this file called getting started, and we see it saved with extension.py to say this is a Python program. So now let's start applying what we learned. So the first thing that we'll do is let's just say name. So let's say the name of this person is Mark. So the second thing that we need is the hourly rate for the salary. So let's say the N25 dollars per hour. And now what we need is we need to find out the number of hours that they worked. So we can just type number of hours there. Let's say they worked 35 hours. And what's the salary? So the salary, we can say the salary is the rate multiplied by the number of hours that someone worked. So that's good. So now let's try to run our program. So I'll go back in the terminal and I'll just type Python getting started. And you see, it, after hitting enter, it's come here in the next line. So meaning it has finished running the program. But as you can see, it hasn't shown us anything that has happened. So what's going on? So we have to tell Python that we actually want to see something here. And what we want to see, let's say we want to see the name. So we have to type print. So the print tells Python that show me whatever I give you. And what we give it is name. We put it in between the brackets. So whatever we put in between the brackets is what Python is going to print out, so we can see. So you might be wondering, where did I get print from? So this is just one of the functions in Python that you can use to print out something. So this is called the function. So this is our first encounter with functions. And there are several other functions that you can use. They actually give you access to doing certain things. So you don't really have to write your own program that knows how to print. You can just use this function that already exists in Python. So let's try it again. So I'll type again Python getting started and see what has happened. Now it's printed Mark. But we also want to see the salary. So we'll type another print below name, and we'll just put a string salary. So you see this has double quotation marks and double quotation marks. So this marks the beginning of the string, and the other quotation marks mark the end of the string. So we can give print several things. We just have to separate them with a comma. So what I want is salary. So as you can see, VS Code is actually doing a good job at auto-completing things for me. So I've put salary here. So now let me run the program again in this terminal. And you see now it's printed Mac and the salary is 875. So this works good. It shows us the salary and it also shows us the name. But let's say you want to give it to someone who doesn't know how to program and they don't know how to open your Python file. So you want the person to just enter the number of hours instead of having to edit your program. How do you do that? So there's another function that's called input. So that function, so I'll put it here, input. So you can also give it a message that it will print to someone to tell them that enter this. So here I'll just say enter hours. So what actually happens is that whatever that someone enters will be a string. So you'll see something something interesting happening here. So let me actually put the rate at the end. Let's run this program again. So it asks me to enter the number of hours. So the way the interpolator actually runs will run from top to bottom. So first they'll start with Mac. It will give it the name, and then it will come to 25 and give it the name rate. And then it will come here where it says input. It will print out that, enter, and then it will wait for me to enter something here. Once I enter that, whatever I enter, input will give it, it will be given a name number of hours, but this will be a string. So let me put, for example, 89. And look at what happens. You have 89, 89, 89, 89, 89. So what it's done is it's repeated this string 25 times because the rate we have here is 25. So that's one thing you can do if you want to actually repeat something in Python. So if you have a string, just multiply it by a number and it's going to repeat that thing, that number of times you multiply. So that's like one thing that you can do with strings. With the numbers, it just multiplies the numbers. So now that we know that this is a string, how can we convert it to a number? So here I've just put, you can just enclose it in float. And this will turn it into a number. So you really don't have to enclose input into a float for that to work. You could also do this. You could assign number of hours to float, number of hours. So you can actually assign a number of hours you can convert number of hours to a float and give it the same name, number of hours. So here what it will do is convert that to a float, then give it a name, number of hours. So it will give it the same name. So now let's try to do this again. And it will ask me to enter the number of hours. I'll enter 89 again. And you see now it's calculated 2,225. So those are some of the things that you should be aware of dealing with strings, is that they behave different from numbers. So there we have it. Now we have a good program that asks someone to enter the number of hours, and once they enter the number of hours, and it will print it out. So usually we don't have to have several lines of code. Sometimes we try to reduce the number of lines as long as it doesn't make it very complicated to understand. So we could actually remove this line and just put it here. So now we've reduced the number of hours, but we've maintained the same functionality. And if we run this program, you see that there's really nothing that has changed. It still does the same calculation. So that's good. It works. And now we can actually ship this to someone, and they can also use our program to calculate the information. So you see the other things that we might want to change. Maybe we might want someone to specify the name and to specify the rate and all that. So you just use input to get any input from a person. So let's say now we've shipped our program to someone else, and this company is excited. They've paid us a lot of money and they want to run our program to calculate salaries for their workers, and they run the program. And then now here it says enter number of hours, and now the person doesn't know whether to enter a number or just to type it, and they enter 10 as a string instead of a number. And what happens? The program gives them an error. And they give you a code that the program is not working, it's crashing when I enter my hours. And you don't really know how they're entering the hours. They're not entering numbers. Instead, they're entering a weight 10. And our program doesn't really know how to deal with the number 10, with the weight 10. It knows how to deal with the number 10. So we have a bug in the program that we didn't consider. We didn't consider that someone could actually enter a weight instead of a number. So we go back to see the program, since we're already spending the money, and we try to run it and ask them to enter how they entered, and we see that the program is crashing. So what do we do? So the first thing that we do is to read the error message, because after reading the error message, that's when we can fix the problem. So we see the error message here. It says value error. So the next thing is, so usually you always go to the bottom of the error to see what it says. You see value error here, and you read the information that it gives you. It could not convert a string to a float. And what string was that? 10. So you just go in your program and see where you have this float. So you see, that's why you're converting input to this input, which is a string. So we're converting this string. We want to convert it into a number with float, and we see that that's where the error is happening. So we now understand the root cause of this error, and so what we're doing now is what's called debugging. We're trying to find the root cause of the error, and we want to fix this error. As you can see here, we can't always anticipate what the user is going to do with our program. They might use it in a way that we didn't really plan for it to be used. So in the next video, we're going to see how to handle errors, to anticipate some errors and how to deal with them. For example, here, it would be very useful for the person, instead of the program crashing, if we could tell them that what you entered is wrong. You don't enter the words, you have to enter the actual number. That would be very useful for a person, instead of just showing this error that they can't even understand.